So this is my first ever talk at a convention, so you'll forgive me if I am a little hesitant. So first I want to give you a little bit of background. For years, Barry Warsaw, I do know your name even though I just call you Barry. Okay. And along with the Python SIG, we're the maintainers of the email package in the Python standard library. And it has a very long history. It started, well, I don't know all the history because I wasn't around for it, so I won't try to go into that. Barry also wrote and helps maintain the Mailman package, which he'll be talking about as the next talk. He was involved in the port of the email package from Python 2 to Python 3. And that port had a bit of an issue. So the big transition from Python 2 to Python 3, as you know, was changing the fundamental string type of Python from what was essentially a binary data type to Unicode. So the email package is designed to deal with email messages, which to our minds means text messages, right? Something readable is what we're trying to transmit from one person to another. So logically, those are strings. So you would think, okay, well, this is really easy, right? Everything's strings. Now everything's Unicode. Well, no. The transmission protocol for email is a binary data format. There's actually the RFCs that explain how all of this stuff is supposed to work, give a way to translate binary data into ASCII-only data. And when all this stuff was done, binary data, that was the only way you could transmit non-ASCII characters, things that weren't English. So if you wanted to internationalize something initially, you had to use binary. You had to use an encoding like Latin 1 or one of the other various encodings. So this was all pre-Unicode. So really, in that intermediate stage, email is binary. So the data that a Python 3 email package needs to be able to handle is binary data, but all of the algorithms that are in the email package deal with text. So that proved to be a problem. So what wound up happening is that in Python 3.1, email could only handle ASCII data. It could not handle a binary message that was received off of the wire in an email transmission. So that was a major problem. Now, to solve this, you figure, well, we're going to have to rewrite all these algorithms so that they can handle binary. So Barry started that rewrite several times, and it was a major bear. I mean, it's just not an easy thing to do. Now, 3 years ago, I got involved as a Python contributor. I've been using Python for many years in my work, but I decided I actually wanted to make contributions to the Python project itself. And I was attracted to the Internet Protocols piece of the standard library because most of my career has been involved with Internet Protocols one way or another. I was director of technical services for a couple of small ISPs for a number of years, so I've done a lot of server work, I've done a lot of email work, you know, how does all this stuff work? I understand that protocol level pretty well. So that setup, that's the past, all right? So now, the next step was, I joined the email SIG, because that was one of the things I was interested in, and there was an ongoing discussion about, okay, how are we actually going to make the email package in Python 3 work? How are we going to be able to actually communicate with all those mail servers out there that are sending us binary data? So I participated in that discussion and sort of became the secretary and collected all the ideas and put them into a format that everybody could look at and say, okay, yes, that's what we agree with. No, that's not going to work. And we came up with a plan. So we figured, well, okay, it's Python 3. Forget about backward compatibility. We're just going to rewrite this thing so that it works right. We're going to redesign the API so that it's easy to use. This is the modern era. We want to be able to handle internationalized text. We want to be able to handle Unicode as the first-class citizen the way the rest of Python 3 does. So we're going to need to change the API. We're going to need to change whatever we need to change underneath to make it all work. Build a plan. And then we figured, well, we'll do that, and then what we'll do is we'll write a backward compatibility layer that can wrap those new APIs and provide the old API. Seemed like a good plan. So I proposed that I would do that rewrite. I'm an independent consultant, so I could have time available if somebody could pay me some money to do it. So I put that proposal out, and the PSF gave seed funding to get the project started. So I began that rewrite, and that, I started digging down into the underlying layers and figuring out, okay, now, how do we handle text and binary? We want to handle text, but we have to handle binary. Do we make a dual algorithm? Do we use the tricks where you have to use slices to get a single character out of a binary string so that the algorithm can be the same when we're processing text or when we're processing, so there were lots of possible ways to go about it, but what that means is that I became very familiar with the algorithms that were underlying that. Now, in the meantime, Martin von Lewis came up with the idea of the surrogate escape handler. This is a way to take binary data and put it in a Unicode string in a way that preserves the meaning of the binary data so that you can get it back out again later. And this is used to handle binary binary file names that come from the file system, where you don't care what those binary bytes are. All you care is that it represents the name of the file. So you read it in, move it around in your program, use it to open the file. You need those bytes to be preserved, but you don't care what they are. Okay, fine. So that was one piece of a puzzle. The other piece of a puzzle is that Antoine Petreau took the NNTP package, which has a lot of the same problems as the email package does, but actually deals with, the NNTP deals with binary data in a slightly different way. So he rewrote the NNTP package so that it worked with Unicode in Python 3. And one of the tricks that he used was that same one that Martin used, where you get the header in from the NNTP server, you don't care what the binary bytes actually say, you just preserve them, and then when you send them out again, you reconstruct them. So when I saw him do that, I thought, okay, so you actually can manipulate binary data using the standard Python text tools if you don't care what those binary bits are. All you care about is preserving them. So based on my knowledge of how all the email algorithms work under the hood, I looked through and I said, yeah, okay, so just carry the bytes along here, carry them along here, make sure that when the user asks for a string out of the API here, okay, well, now it's an invalid byte, so we're going to have to do something with it, so we'll turn it into a Unicode unknown character. So that's a hack, but it's a hack that works. So that's the present. Python 3.2 was released with full binary support in the email package. You can read a binary data file off the wire. You can manipulate it. You can send it back out. There's a binary generator that will reconstruct the bytes that you got and resend them as long as you didn't try to change anything. Now, if you had to change something, you're going to change them into Unicode unknown characters and then on the back end. Or you might wind up with an unknown 8-bit encoding in your header. It says, I don't know what this was, but here they are, right? But it works. So that's the present. Now, going on to the future, what happened next was that the QNX Corporation was very interested in Python and email, and they called me up and said, do you want funding to complete this project? I said, sure. And so they paid me to continue to work on the email package and bring it into the full Python 3 future using that new, sort of right into that new API that we had designed. Now, you will recall that I said in that new API we were throwing backward compatibility out the window. Well, don't worry about that, because as it turns out, the way we wound up implementing everything, we actually retained full backward compatibility. So it's interesting to know that QNX is actually using Python 3. If you know the playbook version 2.0 has this new PIM application, Personal Information Manager, and one of the, it talks to all kinds of servers and unifies everything into a single inbox. And the back end of that, the thing that talks to all those servers, is written in Python 3.2, which I think is really cool. All right, now, what's going on here? So, email, past, present, and future. The past is Python 2, the present is Python 3.2, the future is Python 3.3 and beyond. The email package has an internal version, and this is because it started out as an external package, and there are programs out there that test the email version to see whether certain features are provided. So in the past, it was email 4 and earlier. 4.0.3 is what's in 2.7. The present is email 5.1. Email 5.1. Python 3.1 was released with email 5.0, which was the basic port. 5.1 adds the binary support. The future we're calling email 6, because we're going to change the API, or we're going to add to the API. All right, so in email, everything works great as long as you are working with ASCII. Create a text message, turn it into a string. It does the nice little MIME things. Character set US ASCII, all good. Try to use Unicode, and this is Python 2.7. You can see the little U there. Doesn't work quite so well. But it does work, okay? So the way you actually do it is you have to tell it, I want you to encode this message using the character set Latin 1 in this example. And it goes and does the encoding, all right? So it uses the quoted printable content transfer encoding. So that works, but it's kind of annoying. All right, so we can use, I'm sorry, let me back up one for a second. So this is a binary string that we're giving as input, so we have to tell it what character set that binary string is encoded using, which is Latin 1 in this case. We can also use Unicode and tell it what character set we want to encode that Unicode to, so that works just as well. Now in the present, if we use Unicode and we tell it what character set we want to encode it to in the message, that works. Okay, so that's the way you do it. In Python 3, you don't have the U in front of the Unicode string. In the future, let's make this a little easier, right? UTF-8 is becoming the default. Let's just use UTF-8 as the default and encode it. Now there's a little trick here that I'm hiding, which is you'll see that quoted printable, encoding is using quoted printable, but in fact the email package by default will use base 64 for UTF-8 because you might be doing Chinese. And why would you bother with quoted printable if every single character was? So I haven't written this algorithm yet, but what I plan to do is do a little checking to see whether or not the first chunk of the data is going to be what proportion of non-ASCII characters it has. And if it's mostly ASCII, we use quoted printable. If it's mostly not ASCII, then we'll use base 64. I haven't actually written that algorithm yet. That's a plan. Now, it's actually okay to, that's an API change, but it's actually okay to do that because right now, if you don't pass in the character set, you actually get Unicode in the data that you're trying to send on the wire, and that doesn't work. Okay, so more complicated stuff. In email headers, you can't actually put binary data at all. Headers can only be ASCII, so there are various tricks that are used to make this work. So if we try our binary string in Python 2 and as a header, and we encode our message, we actually get binary data in the header, and that's illegal according to the RC. So that's a non-starter. It'd be nice if that raised an error, but it doesn't. So what we do, if we pass in a Unicode string as the header, then the email package is smart enough to say, oh, this isn't, we know this isn't ASCII data, this is Unicode, we have to encode it. So it encodes it to UTF-8 by default. And the header encoder does have the algorithm in it to see, okay, is it shorter if I encode this using quoted printable, or is it shorter if I encode it using base 64 and does the right thing? Okay, so now in 3.2, right, it's all Unicode strings, so everything's going to work great, right? No. I found this bug while I was preparing these slides. I plan to fix this during the sprints. So that's a problem. In the future, though, it'll work better. So this algorithm's already been written. I don't think it's committed to the email6 repository yet, but this works. Not only does it recognize that there's Unicode there and do the encoding, it also looks for the minimum amount that it needs to encode in order to make it work, so that as much as possible is readable in plain text. Okay, addresses. Addresses are even harder. So we have this function, format address, which will take your display name and your actual email address, what the RFC calls the adder spec, and combine it into the correct string, except that if you pass it a binary string, it doesn't do any encoding. It, again, passes binary data in, so that's not helpful. Okay, so let's try passing Unicode in. Well, then we get a Unicode string back out. Okay, great, so we can put that in as our header and email will automatically encode it, right? Well, yes and no. That's not an RFC valid address because you don't have little @ sign and various other, the adder spec cannot have Unicode data in it, at least not in the username part. So now a lot of email clients will actually handle that. They'll decode that and then they'll look at it as an actual address after decoding it. So that's called the Pastel principle. If you get garbage, do your best to understand it anyway. But it's not right. So how do you do it correctly? What you do is you have to use a toolkit in the header package to create the header. And here we're appending the display name first and telling it that it's Latin 1 so that it knows to encode it correctly. Then we're appending the adder spec. And now if we encode that header, we get a RFC correctly formatted address. Assign that as the header. Okay, everything's great. But you will notice here that you no longer have that nice little format address utility that knows how to quote things properly. That doesn't actually matter because if you encode the, if you use an encoded word to represent the display name, it is a single atom. There's no extra quoting to be done. That's all the quoting you need to do. But to know that, you have to understand the RFCs. You have to be familiar with how all of this stuff is supposed to work. You have to put it together yourself, and that's a little suboptimal. All right, now, in the present, it's not any better, but it works. Future, here's what we want to have happen. All right, so this is actually checked into the Python 3.3 repository already. Format address can understand, this is Unicode, let's encode it. All right, so you don't have to think about that anymore. What we want to have happen, and this is partly coded, is to actually be able to take that string that you got from some other message, assign it to where you want it to go, and have it understand that as an address and correctly encode it according to the RFC. Other cool stuff. Now this is where it gets exciting, okay? In order to do that trick, we have to parse an address header as an address header. And once we do that, then we can do all kinds of other things with that as an address. So now a header that we know is what the RFCs call a structured header. We know the structure, we parse the structure, and we create an object. The object is still a string so that we have backward compatibility, but it has extra attributes. So now we can say, okay, I want the address that's in that header. Now you may wonder why I'm using sender here. I'll explain that in a minute. We can say, okay, we've got an address. I want the name, I want the display name field. I want the address spec field. I want the username out of that address spec. I want the domain out of, okay, so all of that data is now available to your program without you having to do any further parsing. I forget what's here, okay. Now, what we also want to be able to do, so a field that can take multiple addresses, we're going to parse that as an address list. Now we have a list of addresses, so this can give you back a tuple of address objects. The address object, again, has a string representation that is the email address as you would look at it, but it's actually an object, so it has these same attributes. And we'll eventually expose that address object so that instead of using format address to get a correctly displayed string, you would use the address object. This API is not really defined yet. I'm just making something up for the purposes of this presentation. The point is we want to expose that object to you. Now, this is something we haven't decided about. We could do this. We could support augmented addition so that you can add an address on and it will automatically update all of the parsing and do the right thing with the text. There's a different possible future we could have. The email package can know the to address can only appear once in your message. And if you try to add a second one, it's going to blow up. Now you have to understand that normally what the email package does with headers is you add a second, you assign to the same header name and it appends a new header with that name to the end of the list, which is what you want to do with a lot of headers, but not with the ones that are unique. So we'll have to make a decision about how we're going to handle that. Okay, let's see how fast I can get through this. So the add string is just one interface that you can use on a message. So in the past, it took one optional argument, whether you emitted a Unix from or not. In 3.2, there's another optional argument, max header. In the future, what we want to do, so there's lots of APIs that have all these optional parameters. So what we've done is we've added a policy framework so that you can say, here's a collection, here's how I want all of these settings to work, and you can pass it in a number of places in the API, and it will do the right thing because all that data will be carried through. So here's a list of the policy controls that are available. Don't worry about this. There's one thing I want to show you, which is header folding. So right now, Python doesn't unfold headers. If a header comes in folded, the carriage returns are still in the what you get back. What we want to do is we create, so for backward compatibility reasons, it's still going to work that way, but if you pass it in a different policy, the new email 6 policies is probably not going to be the name of the policy, but that's the idea. Then it will do the unfolding so that when you ask for the header, you will get the unfolded version, which is 99% of the time what you want. Same thing with header decoding, right? Right now, you just get back the encoded version and you have to decode it. And in order to get Unicode, you have to create it as a header object, pass it through the Unicode function to get back an actual Unicode string. So in Python 3.2, it's exactly the same, except you don't have the U in front of your string. But what we want to have happen is that if you say decode email 6 defaults, you will actually get back the decode header. So in the past, what the email package was is it's a parser generator, parses email, generates emails. The model that it uses in memory is that of the content transfer encoded message. It's a MIME toolkit. It's RFC 2047 is those encoded words in your headers. In order to use the email package now, you have to understand the RFCs, and the RFCs are really hard to understand. In the present, it's the same as the past, but a little bit better Unicode support. What we want to have happen, it's still an email parser generator, but now the model is the model of the ideal email message, that Unicode text, which is what you're really writing and what you really want your recipient to see. It encapsulates the RFC knowledge so that you don't have to know it. It is backward compatible. What else do we want to do? In order to make this happen, I had to write an RFC 822 parser, so eventually we'll expose that, which is a nice tool. We want to add specialized support for creating MIME objects so that when you read in the message, you don't just get a generic MIME object, you get an image, you get an audio file as a separate object with special methods. Be able to write your message bodies out to external storage so that you're not limited by how much memory you have, which is really good for embedded. Create better integration with other stdlib packages. I want poplib to return you a message object, ultimately. World domination. So there's actually a meaning behind that, which is that one of the other features of the new email package is that it does a lot more sanity checking on the input, and while it will parse anything, it makes little notes about what was wrong. So ultimately, I want you to be able to submit an email message to the email package and get back a complete list of all the RFC violations. All right, that's it.
Thank you, David. If anyone has any questions for him, please come right up here, and you can ask.
Yeah, hi. Thanks a lot for all the great work you've done up to now and the great work that you're going to be doing.
Thank you.
I think it's great. I'm involved with the Mailman Project, and we have some special needs for email, such as, you know, we get an email, we're basically a kind of relaying service, but there are transformations to messages that we don't want to make.
Right.
You know, we don't want to unfold headers and then fold them back in different ways. We don't necessarily want to break signed message parts.
Right.
Things like that. Are we going to be able to do all that?
Absolutely. So that model that I said is the model of the ideal message. That's the view that the user, that the application gets. But behind the scenes, everything is preserved. One of those policy control headings is, you know, don't touch anything you don't have to touch, right? So as long as you don't transform an individual header, whatever you originally got in, that's what you get back out when you generate the message.
Great, thank you.
Over there?
Does it handle attachment very well?
I'm sorry?
Does it handle attachments?
The question for the tape is, does it handle attachments well?
The Python email package in general does. I'm not sure what specifically you're asking about.
Yeah, well, is it easy to send emails with that attachment?
Is it easy to send an email with an attachment?
Yeah, does it require special knowledge?
No, and that's even true currently. There's a set of classes in the MIME subpackage that represent different object types. You instantiate one of those, you pass it whatever your payload is, and it does everything necessary to format that correctly. And we'll make that, I think we'll ultimately make that even easier, but it's pretty easy now.
Yeah, and what about alternate messages like plain text and HTML version? A plain text or HTML version of the same message?
The question is...
Yes, okay, a plain text or HTML version. So you saw, it went by quickly in that slide, but one of my policy types was HTTP. So that means that when I generate a message out of that model, it's going to be in HTTP format, which means there's no folding in the headers. Everything is /r/n instead of /n. Or if you use a policy control that says no binary at all, it'll do whatever transformations are necessary to make sure that that message is rendered completely in ASCII. Or if you say, you know, this is normal email, then it'll use 8-bit where 8-bit's allowed. Not all of that is implemented, but most of it is.
Yeah, what I meant was that usually you want to send both a separate plain text and a separate HTML message in the same.
Yeah. So,
yeah.
And this is still true of the current package, and I'm not sure, we haven't really talked about this part of the API as far as future goes, but you do have to understand a little bit about how MIME messages are structured in order to do that. You have to build the MIME message by putting the attachments in the right place. But there are those classes I talked about, so you have the multi-part alternative class, and then you attach to it your text version, and you attach to it your HTML version, and then it will render it correctly. So you're dealing with objects in the Python library, and then the library deals with actually generating the correct MIME.
Well, I just had two quick comments. First of all, thank you very much for not only doing the right thing, fixing all of the stupid bugs that I added to the email package and all the boneheaded design decisions I made. So really kudos to you, because I think the email packages is really improved for 3.2, and under your tutelage it's going to be awesome for 3.3. So thank you very much for that. The other thing is, I'm wondering, are you going to be sprinting on email package?
Yes, that's a very good question. Right, I will be with the core sprint, but I'll be working on email 6. So anyone who wants to help out, please come.
We have time for one more question.
Okay, so call me crazy, I like to do as much as I can in the terminal and currently use Mutt as my primary email client at work and such like that. I've decided that I should write my own curses-based email client.
That's how I got started on this.
Yeah, okay. And so, obviously you've immediately convinced me that I should be doing this on Python 3 and using the new email package. I'm curious what timeline there is, or maybe if you can recommend some other packages that I should be looking at in the meantime to aid in, just dealing with that and, in the kind of the context of.
Well, there is a package on PyPy, which is this last slide, right? Okay, so the pre-release version is available. There's a bunch of, some of the things I've talked about here, not too much of it, but some of it has not yet been committed to, has not been released on PyPy, but is in the, there's features, sub-repositories on the Python HG site, Mercurial site. So that's there, so you could check out that and use it, or you can wait for me to release the next version on PyPy. I would love to see most of this get into Python 3.3. I don't know whether that's going to be accepted or not yet. I haven't even started that conversation because I have some cleanup I need to do before that would even be possible. Certainly the policy stuff is available in 3.3 because that's already in trunk. But how much of the additional features are going to be there is not certain at this point, but they will go out on PyPy, so you can use that package in the meantime until it actually comes out in the released Python.
Ladies and gentlemen, R.DavidMurray.